In this lesson, now we're exploring finding the trig functions of any angle, not just positive angles, but negative angles as well. And we're doing that in the coordinate plane. If you'll notice in the diagram, they have kind of the breakdown of what each trig ratio is depending upon the coordinates of a point on the terminal side. And this graphic is on the reference sheet. So there you go, one less thing that you have to memorize, and you just have to make sure that you know how to apply it. So if I'm trying to find the 6 trig functions of the angle formed by the initial side and a terminal side at 4, 3, I have to find the hypotenuse of the triangle. So my r is the square root of 4 squared plus 3 squared. And when you work that out, that's 16 plus 9, which is 25. And the square root of 25 is 5. So sine of theta is y over r, so that's 3 over 5. Cosine of theta is x over r, which is 4/5. Tangent of theta is y over x, which is 3/4. And then the reciprocal functions are easy because they are so aptly named. You just have to remember which one is which. Cosecant is the reciprocal of sine, and that is 5/3. Secant of theta is 5/4, and the cotangent of theta is 4/3. Same exact idea in 1b. We have to find the r. So r equals the square root of -2 squared plus -1 squared. And that is the square root of 5. And I know I've been letting things slide as far as rounding. Some of you have been good about using the radical, either because you're comfortable with them or because you have a really good calculator. Let's go ahead and express the ratios using the radical. So sine of theta is y over r. So that's -1 over the square root of 5. But you need to know by now that you can't have a radical in the denominator. So we multiply top and bottom by the radical, and we get negative radical 5 over 5. Similarly, the cosine of theta, this time that's x over r, so that's -2 over radical 5. And if you can use the last example as kind of something to refer back to and see where this is going to go, you might already realize this is going to equal -2 radical 5 over 5. Tangent of theta is y over x, so that's -1 over -2, which simplifies to 1/2. And now I'm just going to take the reciprocals of these. The cosecant of theta, but again, take the reciprocal of the easier thing to take the reciprocal of. I don't know about you, but I don't want to I don't want to simplify a radical twice if I don't have to. I've talked about that in a previous video. Instead, take the reciprocal of this ratio, which ends up being just -square root of 5. Similarly, the secant of theta is going to be the reciprocal of this ratio, which is negative radical 5 over 2. And the cotangent of theta is the reciprocal of tangent, so that's just 2. If it makes you happy to put it over 1, feel free to do so. I see no need to. we're also talking about the angles formed by the axes. So we call them quadrantal angles, and they are 0, 90, 180, or 270, or the radian conversions of those. So finding the exact value of each trig function, let's consider 270 degrees. So 270 degrees would start here and rotate 180 degrees, another 90. So this point could be 0, -1. And once I identify a point, then the rest of it should be pretty easy. That this is going to be x over r. But I would hope that you'd notice that my r, that's the distance from the origin to that point, which is also 1. All right, so this is cosine of 270 is going to equal x over r, so that's 0 over 1, which is just 0. Cosecant of pi over 2 in the coordinate plane, remember that it took 2 pi to go all the way around the circle, which means it would go to approximately 180, no, not approximately, exactly 180 for pi, so pi over 2 is here. And hopefully, eventually, you don't necessarily have to think in terms of degrees so that you can eventually think in terms of radians. Hopefully, eventually, you're able to think automatically in radians. But in the meantime, using degrees as a middleman in your process is fine. All right, so I'm finding the cosecant of pi over 2, or 90 degrees if you want to think about it that way. So I could identify this point as 0, 1. Cosecant of pi over 2 would be r over y. My r is 1. My y is 1. So my cosecant of pi over 2 is 1. In last example on this screen, cotangent of -90. Let's make sure that we realize where that is as far as our quadrants go. -90 is here. So I could pick a point there and call it 0, -1. And the cotangent of -90 would be adjacent over opposite, so that's x over y, which is 0 over -1, which is just 0. And sometimes it's helpful to think about what the signs of the ratios would be depending on where the angle is in the coordinate plane. So let's consider the signs of the coordinates in these quadrants. In quadrant 1, the points are positive, positive. In quadrant 2, they are negative, positive. In quadrant 3, they are negative, negative. And in quadrant 4, our coordinates are positive, negative. So in the first quadrant, if I take a ratio of x and y and r, or x and r, no matter what, it's going to be positive. So all of my trig ratios are going to be positive in that quadrant. In quadrant 2, my sine will still be positive because that's y over r, but my cosine will be negative, and my tangent will be negative. So in this quadrant, the sine will be positive. In quadrant 3, when I take the y over the r, that'll be negative. When I take the x over r, that'll be negative. But when I take the y over x, that'll be positive. So that means that the tangent is going to be positive in this quadrant. And maybe you're starting to realize why I have this advanced students take calculus on the bottom of the board. If you haven't caught on to the joke yet, of course, I will clarify it. And then finally, in the fourth quadrant, the sine y over r will be negative. The cosine x over r will be positive, but the tangent, again, will be negative because it's y over x. So the cosine will be positive. So, what's up with this advanced students take calculus? Advanced students take calculus. Might be helpful in helping you remember in what quadrant a trig ratio will be positive. Here we're defining a reference angle. Please notice that the reference angle is always formed by the terminal side and the x-axis. Always formed by the terminal side and the x-axis. And so it's kind of giving you some rules for how to find the reference angle. Myself personally, I want to memorize as little as I have to. So in the instructions, they're telling you to sketch the angle. And I think once you sketch the angle, finding the reference angle becomes a matter of common sense, more so than of using a formula. If using a formula is what makes most sense to you, then you rock that formula. But I'm not terribly fond of memorizing stuff like this. So here's what I'm thinking. It says sketch the angle. So start with a coordinate grid. 5 pi over 4. Well, I know that's going to be a little bit past 180, and 1 pi over 4 is halfway between the two quadrants. So here we go. If I'm starting here, that's 1 pi. This is 5 pi over 4. So the reference angle is this angle theta. So 5 pi over 4 minus this pi is my reference angle. So 5 pi over 4 minus 4 pi over 4, which is equivalent to pi. My reference angle, therefore, is pi over 4. Part B, negative 240 degrees, means I'm going clockwise. This is 180, and then I have to go 60 more to get negative 240. So there's my negative 240 degree angle. Here's my theta. And if you were listening, I said I had to go 60 degrees past the 180. So my theta is 60 degrees. If I could write. Part C, 390 degrees. There's 360. I have to go 30 degrees more. So again, if you were listening, then you caught that this reference angle is 30 degrees. So how do I use a reference angle in order to find the trig function of any angle? Step 1, according to our text, is find that reference angle. And then find the trig function for that reference angle. And then we use that thing that I showed you before about advanced students taking calculus to determine the sign of your trig function. All right, so in order to find the tangent of 5 pi over 3, drawing the angle 5 pi over 3 might be a good first step. So 5 pi over 3 I know is going to be more than 1 pi. And then how much more? Well, 2/3 pi. I hope that by now your fraction sense is enough that you would realize that 2/3 is more than half. So I need to go past the half in order to get 2/3 pi to get here. Okay, so let's think through this. If this part here is 2/3 pi, then it should make sense that this, what's left, which is my theta prime, is 1/3 pi, or pi over 3. Well, since we know that pi is 180 degrees, we could say, let's think of this in degrees, since some of you might still be kind of getting your feet wet on these radians and getting used to them. So what I need to find then is the tangent of 60 degrees. And this is one of those things that you will be expected to kind of memorize. Although, if you know how to use the unit circle that's on your reference sheet, then you should still be in good shape. All right, so let's consider 30, 60, 90 triangle. There's a reason why I did this. If in my 30, 60, 90 triangle my hypotenuse is 1, then my short leg is 1/2, and my long leg is radical 3 over 2. So the tangent of 60 is opposite over adjacent, and when I take radical 3 over 2, divide it by 1 over 2, those denominators cancel out, and I just have radical 3. Okay, so the tangent of 60 is radical 3, so that means that the tangent of pi over 3 is radical 3, and that means that the tangent of 5 pi over 3, well, is it positive radical 3 or is it negative radical 3? Remember, all students, or not all, advanced students take calculus. So the tangent is not positive in that quadrant, it is negative. And so there's our answer. Part B, because we need some practice on this. Again, drawing the angle, probably a good first step. So when I draw the angle, I know that 5 pi over 6 is less than 1 pi, so it's about here. There's my angle. And how much shy of a full pi is 5 pi over 6? In other words, what's my theta prime? Theta prime is, well, let me go step by step actually. Theta prime is 1 pi over 6. Because if I take 5 pi over 6 and I add 1 pi over 6, I get the full pi, which would be 180 degrees. And so you probably noticed that I started to write 30 degrees because we know that pi is equivalent to 180 degrees. So 180 divided by 6 is 30. So what I want to find now is the sine of 30. And coming back to this 30, 60, 90 triangle up here, when I take the sine of 30, I'm going opposite, which is 1/2, over 1. So that's just 1/2. And so that means that the sine of pi over 6 is also 1/2. Again, advanced students take calculus. The sine is positive in that quadrant, so my answer is positive 1/2. Finally, secant of negative 135. Start by drawing it. Negative 135, about here. It's not going to make it to the full 180. And how much shy of that full 180 is it? It's 45 degrees, so that is my theta prime. So what I want to figure out is the secant of 45 degrees. Well, now I don't want this 30, 60, 90 triangle. I want a 45, 45, 90. And my hope is that after you do these triangles a couple of times, you'll memorize that in a 45, 45, 90 triangle, if my hypotenuse is 1, my legs are both radical 2 over 2. And I showed you this in the lesson video on special right triangles. So secant of 45, that's defined as hypotenuse over adjacent. So hypotenuse is 1, adjacent is radical 2 over 2. Oh, dividing by that fraction just makes me sad. So instead of dividing by radical 2 over 2, I hope nobody has a real problem with my saying that I'm taking 1 and multiplying it by 2 over radical 2. So, of course, I want to rationalize that denominator. So I multiply top and bottom by radical 2, and secant of 45 equals 2 radical 2 over 2, which is just radical 2. So secant, remember, is the reciprocal of cosine. So when I'm looking at the advanced students taking calculus, notice that my angle is not in the quadrant where cosine is positive. So that means that the secant of negative 135 is negative radical 2.